Hello everyone, and welcome more back to my lecture about microservice. This is the last chapter. In this chapter, we're going to talk about the delivery process or how we're going to move our code from the development environment to the production environment to the different environments in our pipeline. Let's start by having word about manual deployment or follow a step-by-step guide to deploy manual your microservices in the different environment. We know that something that doesn't work for microservice because we can have many microservices, many instance by microservices, and we can have also have many environments. Something that doesn't work because we are not going to spend a lot of time by deploying uh, every microservices in the different environments. That's what we need to ensure or to reduce the time to market is kind of automation. That automated pipeline is going to move my code automatically from the different environment and to have automated tests also in this pipeline. The automation can give us the reliability of the system because the scripts will be developed and tested many times before start using it in our environment. And in the meantime, we can have a repeatable deployment or frequent deployment. We can deploy many times, for example, a days and we can ensure to reduce our time to market. So we're talking about continuous integration, we are talking about build process, but also talking about tests. But test is the main idea here in automation. If you want to have automated pipeline from the development to the production environments, how everything should be automated. Uh, Tests, when I'm talking about tests, I'm not talking about the functional test or non-functional test, but also the verification. The way we are going to verify the quality of our code, the complexity of the code is as expected, the code coverage is as expected or not. So we should have many points to check in our quality gate to be sure that we are going to move from the development to production. We're not going to create any issue in the system. So about our release pipeline, as I said, something is going to start in the build environment and finish with deployment environments, and we have many steps. And in those steps, we can run our unit tests, we can run our code verification, we can run the security tests, we can run the performance tests, and at the end, we can run also the end-to-end test of kind of smoke test to be sure that the change we made in our microservice not going to impact the collaboration between all other microservices. So another point that we should ensure also in creating automation to automate the creation or to automate the maintenance of the environment itself. So we have different environment tests, QA, uh, end-to-end environment, etc. So all the steps should be managed automatically as kind of infrastructure as code. So kind of scripts or declaration configuration files, YAML file that we will have all the configuration that we need per environment. If we want to provision, for example, some environment for the quality test, so we will just to create or to execute the script to create the environment, execute the test, and after that we can destroy the environment. So those scripts can be managed using a specific language from the cloud provider, or you can use some kind of agnostic languages or agnostic technology like Terraform, or you can use if you're using Kubernetes as an orchestrator, you can use the Helm or Kubernetes manifest to create and to maintain your environment. So, Artifactual Registry is the way that ensures that the same version of my code. And if, let's take an example of ordering services. I have a version 131, for example. I built this version from my my code, my repository. So I will take the same version and go through the different environments in my system, and the same version of the code will be installed in the different environments of the system. Sure that the configuration is going to change depending on the environments, but still the same code. So I'm sure when I come to the production environment that my version of code has been tested in different level in my pipeline. So to deploy, for example, in Kubernetes, there are some YAML file, manifest file that can be managed to manage all the desired states or all the configuration about the microservice. So here we can talk also about the strategy or the way to upgrade in my microservice. The main rule as grading one microservice should not require all microservice to be upgraded. I think it is the first rule we talked about when we start talking about microservices. This is the independently deployable. When we're talking about independently deployable, it's not only that the microservice has its own workload, but also the impact for the collaboration. We make a change, we should not create any impact in other microservices. So, and I make a change in my microservice, I will deploy it directly to the production environment, sure through to the pipeline. I should not impact any other microservice. So to have this strategy for updates or to manage the update in different version, because we can have, for example, some service one is using service two for some stuff, we should to reduce the unavailability of the system. There are many upgrade strategy, and one of them is the stop V1, start V2. You have also the blue-green strategy and the rolling upgrade strategy. So if we start with the stop V1, start V2, it means that we are going to replace the V2 of my microservice, V1 of my microservice by the V2 of my microservices, that it needs a short period of availability because we need to stop the service to replace the vendor and to start the service again. So another way to reduce this downtime is to have a kind of green and a blue-green swap. Blue-green swap means that we have the version one of my microservices behind the load balancer. My load balancer is routing all the requests to the V1 of my microservice. I start installing and configuring all the V2 of my microservice, and once the readiness is up and running and my service is up and running, I can swap my load balancer to route all the traffic to the V2 microservice. In this time, we minimize the downtime of my microservice. Another strategy is called the rolling upgrade strategy. It's when we have multiple instances. Let's have an example of three instances of my V1 services. So if I have a load balancer, is balancing the load between the three instances. At this time, I will start by replacing only one instance of my microservice. So I will instance the first instance. My load balancer is still balancing the load between the three instances. So my service is always up and running. After that, I'm going to replace the second instance of my service, and after that, the third instance of my service. So I made the upgrade of my microservice without any downtime. So it's sure there are some prerequisites for the rolling update, and the most important of them is that my microservice should be stateless because we are going to replace the vendor of my microservice. And then the second one is that my V2 should still support the V1 request. This is one of the prerequisites of the rolling update. So when you come to the last point in this presentation is about monitoring. Mm, That's sure we have many things to monitor when we use a microservice architecture. So we have many process running on many hosts. We have our pipeline that also must be monitored. So the idea is to have a centralized platform or centralized dashboard that can give us the health or the status of my system. When talking about the status of my system, it's not only about the workload in the production environment, but also in others environment. And the same time is the status or the health of my pipeline environment. So to be sure, all the microservice goes through the steps in the pipe of my pipeline, and there's no problem with any steps in the pipeline. For example, if we have a microservice and running security tests, if there is something in the security problems that we should be alerted, we have some alert that should be programmed to alert us to stop the deployment and in the meantime to alert the people uh, about the problem that we have. So To do so, we have to distinguish between different level of the monitoring. The first level is related to the host itself. So we should monitor the CPU percentile, the memory usage to configure some alert in the system. We should monitor also the application metrics or everything related to the application, the HTTP request, the number of the requests we get, the error we return, the queue length, and the health check of the system. The third level is the log. We should monitor the aggregated log. We talked about standardization. We should standardize the log output, and after that, we should set the aggregation system like Kibana or application insight, and to have all the log aggregated into the system, and to have some kind of alert configured in my system. Let's, for example, if I have the number of errors, an authenticated error for a one that exceed a given threshold, so it should start to react to this event by sending an email or stopping something else. So this is some alert that should be also be configured in your log or your monitoring environment. So the main idea here is to take advantage of the built-in monitoring and observability capabilities on your microservice hosting platform. If you're hosting your microservice in the cloud provider, you can find many features available for you. You have just to configure them and to start using them. If you're using a built-in data center, or if you're installing something on premises, that's true, has become very hard to have all this observability in the site, but you can find many products in the industry that can give you the ability to have this observability in your system. So here I think everything is said and done about microservices. Thank you for having me during this lecture, and I hope I see you soon. Thank you very much.